Among the unusual aircraft at DARPA's Heavy Lift Challenge, this one could pass for a scaled-down conventional helicopter. One main rotor provided lift, a tail rotor controlled yaw, and a slender tank sat below the frame. But it was competing against electric aircraft built around motors and batteries. Xtreme Aerial Concepts had chosen a different source of power, and it would change both how the aircraft carried weight and how the team decided when to stop adding it. Large helicopters commonly use turbines because they deliver a lot of power for their weight. Shrinking one far enough for this competition is much harder. Conventional reduction gearing and support hardware can erase the advantage before the aircraft ever leaves the ground.
We had the idea to combine the step-down gearbox inside the engine. So we are more or less the only ones that combine a turboshaft engine with the gearbox. And so it ended up in an design which is just 8 pounds, that size, 23 horsepower, continuous 24 transient. So the leverage is very high, the power density is extremely well.
The turbine drove the main rotor mechanically and burned liquid fuel. Its useful margin could be read in exhaust temperature and drivetrain torque, not just whether the aircraft left the ground. The team used those readings to raise the load in measured steps instead of jumping straight at the 4-to-1 target.
So, and we played it the conservative route. So we started with 110 pounds on Monday and adding another 20 pounds every other day.
By day 4, Xtreme had completed a 3.04 course and briefly led the field. The next day, its 54.9-pound helicopter carried 181.9 pounds through the full mission at 3.31. The run looked controlled enough to suggest there was more available. On the final morning, the team tested a 3.71 load. The helicopter got the load off the ground, but it began to settle, showing that it did not have enough power in reserve for the full course. They returned, removed weight, and selected 3.45 for the scoring run. Now the turbine had to turn that caution into 5 completed nautical miles. The loaded helicopter accelerated hard on each straight, briefly approaching 40 miles per hour, then slowed almost to a pause for every turn. It completed 4 miles, landed to release the payload, and launched again. The final unloaded mile traded payload risk for a different countdown, the fuel remaining in the clear tank. As the aircraft turned back toward the pad, the team had to wait and see if that reserve would hold.
Look at the fuel turn. Yep, just enough fuel, not too much, not too little. And all we need to see is for them to come in and make that landing on the landing pad.
Here is the landing.
Just need to see them touch down to the center of the plate in the circle.
Dead, solid, perfect.
Doesn't get much better than that. Look at that rotor right in the middle of the circle. And
the landing completed Xtreme's 10th run of the week and made 3.45 official. It held through the remaining attempts.
Congratulations to Xtreme Aerial Concepts. Please join me in welcoming them to the stage.
When the final board was called, Xtreme Aerial Concepts had validated a small turbine, a conventional rotor system, and a deliberately cautious test program. Third place brought a $500,000 prize. More importantly, the aircraft completed the event without the crashes that ended many more aggressive attempts. Xtreme did not make the turbine helicopter exotic by changing its shape. It made the familiar shape competitive by fitting full-size helicopter thinking into an 8-pound engine.